Hello guys, I am Dr. SLR Das. Today we are discussing the MOS characteristics. There are three regions of the operation of the MOS transistor: cutoff, linear and the saturations. First region, that is cutoff region. Here the gate potential is less than the threshold potential, while the gate to drain potential VGD will be anything. But here there is, since gate potential is less than the threshold potential, there is no inversion layer or the channel is formed, and therefore there will be no current. So the IDS will be zero, and this type of the operation is called the cutoff operation of the transistor. So when VGS potential is less than the threshold potential, the transistor region is the cutoff region. Next region is NMOS is linear. Now there are two diagrams. In the both the diagram, VGS potential is more than the threshold potential, but the VDS potential in the upper diagram is zero, while in the second diagram it is between 0 to VGS minus VT. Here the channel is formed, inversion layer is formed, and therefore there is a path between source and the drain. In that path the current electrons will flow from source to drain, and therefore the current will flow from drain to source. In case of the electrons, current flow or direction is opposite to the electron movement. Therefore, as VDS increases, IDS will also increase. Output current of the transistor, that is IDS, drain to source current, is also increases. So it will work as a linear resistor now. So if you want to calculate this current, how much it will be, then we can say that IDS depends on how much charge is in the channel and how fast is the charge moving, that is the time t. So IDS can be given by charge of the channel divided by the time required. MOS structure looks like a parallel plate capacitor, so therefore there is a capacitive effect between gate and the body, and since there is an insulation layer is also there, so we can say that there is a gate capacitance is present between gate and the channel. So channel charge of the channel can be defined as a C into V, where C is the charge of the capacitor, V is the voltage across that capacitor. C is given by the gate capacitance, which is nothing but epsilon OX WL upon TOX. Epsilon OX is the permittivity of the silicon dioxide. W and L are the width and the length of the transistor, while TOX is the thickness of the silicon dioxide. Epsilon OX can be given as 3.9 times epsilon 0, while epsilon 0 is the permittivity of the free space, which is nothing but 8.854 into 10 to the power minus 14 farad per centimeter. COX can be given as the oxide capacitance, that is epsilon OX upon TOX. TOX is the thickness of the oxide. So we can say that C can be given as COX into W into L, while the voltage across that is the VGC minus VT. VT is the threshold voltage, VGC gate to channel voltage. So which is nothing but VGS minus VDS by 2 minus 2. That is VGS is the gate potential minus the VDS by 2 is the average between drain to source. That is the channel voltage minus VT. So charge across that channel becomes COX into W into L into VGS minus VDS by 2 minus VT. That is equation number 1. Charge is carried by the electrons because majority charge is electrons. So carrier velocity V proportional to the electric field intensity between source and the drain. So V can be given as, velocity can be given as mu into E, where mu is called the mobility of the electron. E is the electric field developed across that channel. So E can be given as now VDS by L, where VDA is the voltage across that channel divided by length of that channel. So therefore the time required for carrier to cross that channel given by L by V. L is the distance covered, V is the velocity. So putting the V value, so it is L up by mu into E. Putting the E value, it gives L square by mu into VDS. That is equation number 2 now. With these two, equation 1 and 2, we can say that how much charge Q is in the channel and how much time T each carrier takes to cross that channel is nothing but the IDS, that is Q by T. Putting equation 1 and 2, we will get this mu Cox W by L into VGS minus VT minus VDS by 2 into VDS, which is nothing but beta times VGS minus VT minus VDS by 2 into whole multiplied by VDS, where beta is nothing but mu into Cox into W by L. This is the equation, output current equation of the MOSFET transistor in linear region. Now let us see the saturation region. In the saturation region, VGS is again greater than threshold potential. We can say that channel is formed, but now the VDS is now more than the VGS minus VT. So it is more positive as compared to the linear region, and therefore channel will not reach up to the, or the electrons are not reach up to the drain. It gets pinch off before that drain. So this is nothing but a pinch off phenomena. Whatever the electron flowing from the source, it will not reach us up to drain, but it will be terminated, or it will be strike before the drain to the gate. We can say that it is a channel pinch off phenomena. So here IDS is not depend on the VDS, because electrons are not reaching up to the drain, and therefore the this IDS current or the electron motion is not depend upon the VDS potential completely. So we can say that current is now saturated. Now it is depending upon only the gate potential and not the drain potential. So we can say that if VGD greater less than threshold voltage, the channel pinches of phenomena occur near the drain. That voltage we can call it as a VD sat, that is VGS minus VT. Now the drain voltage no longer increases current. It is not depend on the drain voltage VDS. So it depends upon VD sat now. So putting VDS equal to VD sat equation, so we will get beta into VGS minus VT minus VDS sat by 2 whole multiplied by VDS sat, and then putting the value of VD sat as VGS minus VT, we will get beta by 2 VGS minus VT whole square. So this is the equation of the output equation IDS, output current equation IDS of the MOS transistor in the saturation region. So in summary, we can say that NMOS has a three regions: cutoff, linear and saturation. In the cutoff region, if gate potential is less than the threshold potential, then the cutoff region will occur and the output current is 0. If VGS is greater than VT and VDS is less than the VGS minus VT, then the linear region of the NMOS transistor will occur, and in that IDS, output current, is proportional to the VDS. Why? If VGS greater than VT and VDS is also greater than VGS minus VT, then transistor will be in the saturation and output current is proportional to the VGS. And these are the summary of the output equation. For the cutoff region, output current is 0. For the linear region, it is given by beta times VGS minus VT minus VDS by 2 whole multiplied by VDS. And then in the saturation, it is beta by 2 into VGS minus VT whole square. For example, now let us study the numerical. We will be using 0.6 micrometer process for your project from AMI semiconductor devices. TOX is given as 100 angstrom, then mu is given as 350 centimeter square upon volt second, while VT is the 0.7 volts. Plot IDS versus VDS characteristics. Then VGS will be varies from 0, 1, 2, 3, 4, 5. W by L is given by 2 lambda. Then if we are solving, the beta becomes this much, mu into Cox into W by L. So it will given as 120 W by L microampere per whole square. And then putting into that, we will get such characteristics. For VGS equals to 0, the output current will be the 0. VGS equals to 1, there will be a very little current, and as soon as VGS will increases, the characteristics will be improved, and it will be after certain time, it will current will be saturates for every type or for every value of the VGS. We have to move the VDS from 0 to 5 and correspondingly note down the IDS current. So output characteristics will be now looking like this. So thank you very much. Thank you very much.